To start things off, let me thank you for taking the time to attend today's presentation. My name is Lance Zurich, and I'm the product manager for the fischertechnik Education Division over here at Studica. And of course, today we're going to take a look at the fischertechnik, specifically the Agile Production Simulation model, also known as the APS. And this is a new model designed to demonstrate how the current challenges that are faced in production and logistics planning can be addressed, and it's designed to incorporate the best features of previous fischertechnik models. If you've seen our other webinar, you know about those, along with many new cutting-edge innovations. So before we dive into the meat of the presentation and really talk about the APS model, I'm going to provide you with a little bit of background on fischertechnik and its products. Now, the model we're examining today is once again the newest edition of the fischertechnik line of industrial simulation and training models. Now, these models have been designed with the intent of providing a compact, engaging, and a hands-on method for teaching and demonstrating high-end automated systems. The line of fischertechnik simulation models consists of a series of pre-assembled small-scale models which are designed to replicate both in appearance and in function various automated robotic machines and systems that would be commonly encountered in commercial manufacturing processes. Now, the fischertechnik company has been creating tools designed for teaching students of all ages about how technology works for basically 60 years now, all built around their unique building system. Now, what makes this system unique is that unlike other popular construction systems where the components are designed to stack, in the fischertechnik system, it's designed around a core building block that allows attachment from all six sides. Because of this, it allows for almost limitless design possibilities. In addition, many of the parts are designed to slide together and lock in place using a tongue and groove assembly method. And the hundreds of very specific parts that are available will also help technical builders to address equally specific design needs, which makes it great for things like the model we're going to be looking at today. The system was created back in the 1960s by German inventor Arthur Fischer, who's noted for countless innovations used in both the construction and the automotive industries. Mr. Fischer, at the time of his death in 2016, had held more patents in his name than Thomas Alva Edison had amassed during his own lifetime, which is pretty impressive. Just to give you an idea, prior to creating fischertechnik, Mr. Fischer was first noted as the inventor of synchronized flash photography. This was back in 1949, and a few years later, he gained fame as the creator of the expanding nylon wall plug, which many of us have used. It's commonly used in conjunction with a screw or a bolt to help anchor heavy objects to walls. His company, the Fischer Group, continues to employ thousands of workers all around the globe, producing many variations of fastening devices like this that are used in building construction. And up until recently, they were also involved in the production of components used in the automobile assembly process. In addition to this, they're also well known for providing consulting services to companies who wish to employ state-of-the-art manufacturing processes. Now, many people who are familiar with the fischertechnik line of construction sets, uh, basically you'll notice that with the focus with those building sets, whether those intended for the retail market or those that are designed for classroom use, the focus has always been on helping to foster an understanding of technology. Now, the sets designed for use in the education sector are most often focused on a specific subject area that falls under the umbrella of what is commonly referred to as STEM education these days. And these sets will usually address topic areas such as mechanics, pneumatics, robotics, renewable energies, and things of this nature. And what happens here is typically students would use these sets in the classroom. They'd be asked to build a progression of models using, again, the unique fischertechnik building system. And as they build the different models in the progression, they then perform various experiments which allow them to explore and understand key aspects of the subject being studied. Now, the line of fischertechnik simulation solutions, which of course includes the model we're going to be looking at in today's presentation, is something much different. The line consists not of kits, but of a series of pre-assembled small-scale models, which replicate, again, in appearance and function, various automated robotic machines and systems. Some of the types of models that you're going to find in the fischertechnik system will include things like conveyor belts, punching machines, three-axis pick-and-place robotic arms, color sorting lines, and even high bay warehouse storage systems. Now, besides these individual models which focus on specific automated processes, fischertechnik also offers numerous variations of an integrated factory simulation model. Now, what will happen most commonly is these factory simulation models will consist of four or more individual workstations. Most frequently, you'll find a vacuum gripper robot, a high bay storage warehouse, a multi-processing station with an oven, and a sorting line with color detection, which are designed to all work together as one self-contained material cycle. Now, other variations of the factory focus on the idea of Factory 4.0, which utilizes IoT, Internet of Things, in the form of controlling and monitoring the actions of the factory from a web-based dashboard. Now, as we have a full-scale webinar presentation discussing all of these models in detail, I'm not going to touch on them here, but I would strongly urge you to attend an upcoming presentation if you'd like to know more about these. Or, of course, you could also reach out to me directly for more information, and I'll provide information at the end of this presentation on how you can do that. Now, before we begin our overview specifically of the Agile Production Simulation model, I'm going to very briefly outline some of the advantages of working with fischertechnik solutions. First, fischertechnik simulation solutions allow educators to offer engaging, hands-on tools for teaching, exploring, and understanding various aspects of automation and programming. Now, this can be for understanding how automated systems work, or for having a tangible physical system to observe and work with in a programming or PLC-focused learning environment. The models, once again, are designed to realistically replicate, both in appearance and function, common automated systems. Things, again, like conveyor belts, sorting machines, robotic arms, and much more. Because of their compact size, they're not only ideal for use in the classroom or in-office demonstrations, but they're also great for demonstrating software or other technology-based offerings in a trade show environment. The next factor, and a very important one, is quality. Each fischertechnik simulation model is a hand-assembled, high-quality German-made product. The majority of the models in the fischertechnik simulation line, including, of course, the Agile Production Simulation, which we will look at today, are 24-volt models, which are designed specifically for use with the latest industry standard PLCs. Now, while the APS model we will look at today already includes all the PLCs that are necessary for its use, in fact, it includes several Siemens PLCs. These other models, the 24-volt models, can be controlled with the PLC and programming of your choice. So if you choose to work with some other controller with these other versions, you can do that. Now, you can also use your choice of programming languages in most of the other models. Like I said, this one will come with its own programming and with the controllers already included. But for example, with the other models in the fischertechnik 24-volt line, if you want to use structured text language or ladder language or what have you, that's your option. Now, finally, fischertechnik simulation models are cost effective. Now, if you've had the opportunity to look into any of the other hardware-based industrial simulation options that are available in the marketplace, you'll pretty quickly see that the entry point can be quite high. Now, fischertechnik simulation models, on the other hand, have an entry point at just a fraction of that price. You can get in for just a few $1,000s. And again, they're also compact, they're realistic, and high-quality learning and demonstration tools. Now, while admittedly the new APS, the Agile Production Simulation model, is at the high end of the fischertechnik product range, the price point is still very affordable compared to these other models where, again, you might be talking about an entry point of $80,000, $90,000 or more. And you would really be hard pressed to find a truly comparable solution currently available at any price. This is a very unique model we're going to be looking at today. So with that being said, let's now move on to our discussion specifically of the Agile Production Simulation model and looking at what the term Agile Production means and why it's important. So to start off, here's a slide that I've used in several of the other fischertechnik webinar presentations I've done over the years, and it essentially shows an early version of the Henry Ford style production line model that was used in automobile assembly. Now, the Ford production line was in its own time a very innovative thing in that it streamlined production back in an era when the focus was on efficiently producing a large quantity of the exact same thing. Now, in the case that you see in the photo here, workers along the assembly line each focused on a very specific part of the automobile production process. Excuse my, I seem to be garbling a little bit here. They would each focus on a very specific part of the automobile production process. For example, let's say installing a specific component like a wheel or what have you, and then making a certain adjustment on the automobile before the vehicle is then moved further along the production line where the next worker in line would perform the next action, and so on and so forth until the assembly of each of these units would be completed. Now, again, when the goal was to produce a large quantity of the exact same thing with no changes, this worked really well. Of course, things are no longer quite so simple, and with good reason. Product customization must be considered, as well as the larger numbers of assemblies and components that need to be used. Likewise, the increase in customization options which are available. Product life cycles are also much shorter now than they used to be, with an increase in overlapping product launches and production mix. In addition, flexible manufacturing requires an increase in logistics processes. So to summarize, industry must now deal with smaller batch sizes during the production process and increasingly complex processes. Now, this requires companies to better synchronize production and logistics, to make investments in cutting-edge automation equipment and processes, and to be as overall efficient as possible. Now, as an example, consider the production of a modern automobile. And for this example, we're going to look at the BMW 3 Series, which is shown here on your screen. The manufacturing process for this model must be set up to efficiently and cost-effectively address the 18 different engine options available to consumers, as well as the 5 different equipment packages and 70 different individual equipment options. Now, clearly, in a case like this, the old school Henry Ford assembly line, which again was designed to quickly produce a high quantity of a single specific model, simply is not going to work anymore. And so it's with this in mind that the industry has increasingly transitioned from the assembly line production method with its rigidity and constraints to methods such as the matrix production model, which eliminates the fixed time cycle and sequence of processes, or fluid production models, which also allows for an unlimited number of assembly scopes per station. Now, the most notable benefits of incorporating such agile production methods are in the area of flexibility, including the increased flexibility in production processes, being able to off customer specific mass production while avoiding overcapacity, and also reducing lead time through a mix of different derivatives. An additional benefit is being able to produce goods as specifically dictated by the wants and needs of your customers. And this is why fischertechnik created the new Agile Production Simulation, which is the latest variation of the fischertechnik factory model, this time not only incorporating IoT and state-of-the-art manufacturing processes, but also AI. And in addition, this innovative new model also includes a digital learning platform. Now, here's a quick look at the full factory as it would be assembled on a tabletop. Give me a second to get a drink here. Now, as we've just seen, forward-thinking companies rely on automation, to deal with these complex issues. And that is where the fischertechnik Agile Production Simulation model comes in. It's designed to simulate processes such as quality assurance using artificial intelligence, the functioning of driverless transport systems, and to replicate automated processes on a small scale, from the receipt of goods into the system to modular production to quality assurance. The model includes several features not previously available in the fischertechnik simulation line, including an automated guided vehicle and a six-axis robotic model. The accompanying didactic materials help to translate the hands-on simulated processes into future skills for both students and teachers. And in addition, the digital twin of the model helps to significantly intensify the learning experience. Now, as we're still awaiting the release of a fully narrated video for the factory, I'm going to provide you with a brief overview of each of the workstations or modules, beginning with the section where the incoming and outgoing goods are placed. So this is, of course, the place where the material flow of a workpiece begins and ends. It's a perfect place to start our overview. So essentially what you'll have happen here is that raw materials get delivered at the goods receipt slot. They're positioned on the color sensor for quality control using the six-axis robotic arm with a vacuum gripper, and then they're encoded on the NFC reader. So basically what you'll see here is at the very bottom of your screen, you can see like an electric eye setup. That is where the workpiece would be entered. It would be picked up by the robotic arm with the vacuum gripper and moved over to this station here, where it's the NFC chip is basically encoded, and then it's decided to where it's going to move on for the next spot. The six-axis robotic arm will then place the workpiece that's just been coded onto the automated guided vehicle, or AGV, for further transport. Now, this module also contains the central control unit, I should say the ingoing and outgoing goods module. This module also contains the central control unit, which is a Raspberry Pi, and it also has the environmental sensor, which measures the different environmental conditions at the factory. Now, there is also an integrated movable camera here, which can be swiveled in two axes and will help to provide insight into the entire factory via the fischertechnik cloud-based dashboard. Now, at the end of the work cycle, a finished workpiece, as much as it begins its cycle here, also gets delivered back to the goods dispatch by the AGV. So once it's the order of which pieces go to the workstations could be altered. You could skip a workstation entirely. You could maybe have it go back to a workstation for whatever reason, but that is, of course, up to you. That can be changed around, but just for the sake of giving you a tour here, let's assume it goes to the high bay warehouse first. So in any case, what will happen here is the high bay warehouse contains 9 slots to store work pieces. It has its own stacker crane, and it has its own vacuum gripper that can pick up the workpiece from the AGV vehicle at the docking station right next to this, and it hands it over to the stacker crane for storage. The workpiece is placed into a workpiece carrier for the storage, and retrieval is done according to the first in, first out principle. So basically, your workpiece gets taken off the AGV, stored here in the warehouse until it's needed. Then, if it was needed, it would go back on the AGV and off to the next station. So typically, the next station would be the drilling station. And the drilling station consists of a docking station for the AGV, as all of these modules will have. They'll have a docking station for the AGV to come up to. It has its own vacuum gripper that's used to place the workpiece from the AGV onto a conveyor belt from where it is transported under the drilling head over here. Now, after the simulated drilling process takes place, the workpiece is transported back on the conveyor to the gripper, and then the gripper then places it back onto the AGV, the automated guided vehicle. And this would take it to the next station, which is the milling station. Now, as I have not mentioned it previously, You will note that the high bay warehouse, the drilling station, and the milling station each have its own PLC attached. They're pre-wired to a Siemens S7 1200 PLC, which has also been pre-programmed. I just want to mention this because when you see the pictures of the individual stations, you will see the PLC next to it. That's again already included, already pre-wired. Now, continuing along, what would happen here is the milling station consists of a docking station, again, for the AGV, and a vacuum gripper that places the workpiece onto the conveyor belt from where it is transported under the milling machine. There, the milling of two pockets is simulated, and after that process is completed, the workpiece is placed back onto the conveyor belt and transported back to the gripper. The gripper places it back onto the automated guided vehicle for transport to the next station. Next up is going to be the quality control with AI module. Now, in the quality, along with three different machining features on them, either drilling features, milling features, or a combination of the two, drilling and milling, as well as various possible fault patterns that might be included. So the workpieces get classified using the trained AI at this station. Now, depending on the color, the feature on there, and any possible fault pattern, the workpieces that are then either placed back onto the AGV as being acceptable pieces, okay, or they're sent to the reject container as not okay or defective. Now, just to provide a little more information on the AGV, again, it's of course the module which transports the workpieces from one workstation to another. It's controlled by a fischertechnik's Robotics TXT 4.0 controller, which has been pre-programmed using Python. It's a track-bound vehicle that follows the printed black tracks on the factory floor. It uses ultrasonic sensors to detect obstacles that may be in its place. The vehicle has omni wheels, which allow it to move in all directions. Two buttons and a photo transistor help the vehicle dock to individual factory modules. And the AGV receives its driving commands from the central control unit, again, an industrial standard VDE 5050, and it uses a fischertechnik rechargeable battery pack as a power supply. Since we're talking about power supply, let's talk about the charging station very quickly. When the battery of the AGV, the automated guided vehicle, runs low, the automated guided vehicle will navigate towards the charging dock, where it is automatically charged with a charger with charge monitoring. Contacts on the bottom of the AGV connect to the charging station, and that allows the charging to occur. Now, moving right along, we're going to quickly review some of the technical specifications. This is a 24-volt power supply unit, 11 amps. The central control is by a Raspberry Pi 4B. The individual modules, the workstations, are controlled with the help of five SPS Siemens S7 1200 PLCs. So again, each of the individual workstations we looked at has its own PLC. Additionally, the model includes three fischertechnik TXT 4.0 controllers, which are used to control the sensors and the camera, as well as to facilitate cloud access in the WEWA module for quality assurance AI, and as well as for the automated guided vehicle. There's also a WLAN router for the WLAN network. Software used on the APS model includes SPS programs and structured text for the PLCs, TypeScript for central control of the Raspberry Pi, Node-RED for communication between SPS and the fischertechnik TXT 4.0 controller, Python for programs on the TXT 4.0 controllers, and TensorFlow for supervised learning and quality assurance with AI. Additionally, like most recent versions of the factory training of the fischertechnik training factory, which we discussed in our other webinar, the APS model has a cloud-based dashboard, which can be used for order control and monitoring of the factory status, and all along with determining key figures that may be important and, tracking temperature and things of that nature. The factory itself can be broken down into sections which utilize an easy to put together tongue and groove assembly method like giant puzzle pieces. When assembled, the Agile Production Simulation model has a footprint of approximately 51 by 73 inches, and it has a total weight of approximately 116 pounds. There is a storage case that's also available separately for protecting the model when not in use or when being transported, and we're going to look at that again shortly. And of course, didactic materials are also included. Now, as I mentioned earlier in the presentation, we are still waiting the completion of a narrated video of the factory in motion, but while that is not currently available, I do want to share some raw video that we have of the factory in operation. And essentially what you're going to see here is you're going to see it going through the motion of the various steps that I touched upon earlier. So right now, obviously we're looking at the AGV, the automated guided vehicle, as it navigates the black track. There's a close-up of the AGV, of course, the camera that's on there that allows it to do its motion. The TXT 4.0 controller, which is used for controlling the AGV. Here you have the vehicle coming up to docking with one of the workstations. See it moving along. There you have the router. You get to see some of the components on the factory. The camera that, of course, monitors the factory. This is from the section where the pieces enter the workflow. Also the environmental sensors there, temperature, air quality, lighting, things of this nature. So you see the workpiece enters the process. It gets picked up by the vacuum gripper, gets scanned. There you see it's put on the NFC chip reader. And once all of that's been done, then it can be placed onto the AGV vehicle for transport to the automated high bay warehouse. Again, the automated high bay warehouse has its own vacuum gripper arm, which picks up the workpiece from the vehicle, moves it so it can be placed into a storage tray, which can in turn be stored by the crane at the high bay warehouse. And again, pieces are stored using a first in, first out principle. So if we went back to that dashboard I was telling you about, you can see what pieces are in storage, what pieces are available for, let's say, a customer to purchase. If a customer chose, in this case, to get a white piece is retrieved. And the process is kind of reversed, where the piece is moved so that the gripper arm can, of course, place this piece onto the AGV for transport to whatever station it needs to have a finishing process performed on. So then, as I've mentioned, it can go to either a milling or a drilling station. Where these processes are simulated. Drilling, milling, just kind of putting those two together. Again, you see a close-up of the Siemens S7 1200, one of the 5 included with this. Again, the workpiece continues its travels through the factory. Here it is going to the color sorting with AI. Again, the piece is picked up by the vacuum gripper here, put onto the conveyor belt this model, scanned by the camera. The AI detects the quality of the piece, whether it's a good piece or a defective piece. If it's a defective piece, it's of course rejected. Otherwise, it goes back onto the vehicle for transport to whether it be another station or the end point, which again is the same as the entry point. Again, if a part is leaving the factory, it's again scanned by the NFC reader, and then it's delivered back to the slot where it began its journey. The vehicle can dock and recharge. And that's essentially an overview of the processes. And of course, here you can see how the factory floor can come apart with each module on a piece like this, so it can be stored in the travel case. This is the one thing that's a little bit different than if you purchase one of our other factory models where they all come on one board. This one is able to be broken down into some smaller sections. It still takes up a lot of space, though, because obviously this is a much bigger footprint than the other factories we have. Now, another very important aspect of the APS model, which I touched upon earlier, is the inclusion of a digital learning platform. Now, the digital learning platform is a high-performance, immersive learning environment, and it's based on a digital twin of the Agile Production Simulation. Now, this serves as the educational counterpart to the physical factory model. The learning tool is used to clearly illustrate the control units, the actuators, and the sensors included on the model, and also to demonstrate the full functionality of the APS. The platform offers interactive learning modules on agile manufacturing, IoT, AI, and automation. It enables the simulation and evaluation of highly complex process workflows, in agile manufacturing. The digital learning platform is a byproduct of the partnership between fischertechnik GmbH and the Karlsruhe Institute of Technology, the prestigious public research university located in Karlsruhe, Germany. And please note that there is no additional cost or fee associated with the digital learning platform. It is included in the scope of delivery when you purchase the APS. Now, just to give you a better idea, this page helps to illustrate the structure of what is covered by the digital learning platform. Now, as you can see here, users start with an introduction to the Agile Production Simulation, and this begins with an interactive explanation of each of the process modules, as well as of the control units, the actuators, and the sensors. Following this, the main instruction is broken up into 4 separate modules, one focused on agile manufacturing, the second on the Internet of Things, or IoT, the third on artificial intelligence, and the last on automation. Excuse me a second. Each of these units, or learning modules, will include the following: a theory section, establishing a fundamental understanding of the topic at hand, a practice session, and this is where users can simulate and understand the processes being studied with both the physical mode and the digital twin version. And transferability. This is where students get to see how the knowledge they've acquired can be used in the real world. Now, here are some screen captures of the digital learning platform just to provide a better idea of what it's all about. The digital twin forms the foundation of the digital learning platform. And once again, the educational or exploration mode of the APS is implemented using the digital twin. The digital twin can be utilized to solve tasks in the learning modules. And the digital twin can be used to simulate complex challenges in an agile production environment. We're going to just kind of go through some of these slides here. Now here you'll see there are a lot of tools and I can send you a link to the specific section of the manufacturer's website where more detailed information and system requirements are posted for all of this. Flexible, modular, agile, and connected. That is essentially the fischertechnik Agile Production Simulation model. Now, the APS model is the perfect tool to use in higher education. It can be used for advanced CTE training, university labs, and for industrial training. It's an ideal tool for teaching about the future of production. It offers a hands-on learning experience, and it provides a safe method for teaching these skills while also offering a tool that replicates, again, both in appearance and function, those which would be commonly used in industry. It provides a bird's eye view of a working factory, and it, of course, offers considerable added value with the digital learning platform. It's also an ideal for demonstration purposes for companies involved in areas such as IT and software development, as well as consulting. Now, in addition to the APS factory itself, there are now two add-on modules which can also be incorporated if one wishes to expand the functionality of the model. The additional annealing furnace, shown here, unlocks more learning content in the digital learning platform. Both theory modules and additional tasks in the Agile Manufacturing Learning module are made available. And these cover topics such as introducing new derivatives into production and expanding existing production configurations with an additional process. Now, this module, like most of the modules of the APS, includes its own Siemens S7-1200 PLC, which has been pre-programmed in structured text. As an FYI, the annealing furnace module has dimensions of approximately 22.5 by 15.9 inches with a weight of by 15 by 9 inches, with a weight of approximately 10 pounds. It is, of course, designed specifically for use in combination with the APS model. This is not designed as a freestanding workstation. So again, if you're interested in purchasing the annealing furnace or the next model we're going to show you, these are models that always have to be used in conjunction with the full APS. They would not be used on their own. The second module, which is available for purchase, is an additional AGV, an additional automated guided vehicle, which can also be added to your model. Now, like the annealing furnace, the add-on automated guided vehicle will also unlock further learning content in the digital learning platform. And again, both theory modules and additional tasks in the Agile Manufacturing Learning module are made available. And these will focus on agile intralogistics, as well as the parallelization and prioritization of the production workflow. Now, this model does ship with a pre-programmed fischertechnik Robotics TXT 4.0 controller, and is with the version included with the APS. Again, the programming is in Python. This can, of course, only be used, again, in combination with the APS model and is not intended as a freestanding model to be used on its own. The dimensions for the model are approximately 10 by 7 by 5.5 inches, and it has a weight of just about 3¼ pounds. Now that concludes the main portion of the overview of the fischertechnik Agile Production Simulation model. So now let's look at the costs that are involved. For the Agile Production Simulation model, which again includes 5 Siemens S7-1200 PLCs and 3 fischertechnik TXT 4.0 controllers, as well as the digital learning platform with the digital twin, you are looking at a cost of $35,174.95 each. The add-on module, the first one, the annealing furnace, this again includes its own Siemens S7-1200 PLC already. It does unlock additional didactic content in the digital learning platform. The cost for this unit is $4,439. The additional APS automated guided vehicle also unlocks additional didactic content in the digital learning platform. The cost for this is $2,589 per unit. Now, as there is one more item to cover very quickly, that is the storage and transport case, which is designed especially for the Agile Production Simulation model. Now, as the APS model is obviously a substantial investment, this is really an important option to help protect the model when not in use. And of course, if you upper and a lower half. Each of the two separate case sections has steel tilt handles and angle protection corners for additional stability. Now, there are also straps and internal zipper pockets for storing cables, cords, workpieces, other accessories that are used here. Now, the lower section of each case is lined with hard foam, while the upper sections have some foam to help cushion the various work modules while in storage. The dimensions of the case are approximately 48 by 32 by 29 inches, and it has a weight of approximately 75 pounds unloaded. And so essentially, when the APS model is loaded into the case, the total weight of case and model are about 190 pounds altogether. Please do note that even when the model is kept in the storage case, if you do end up having to transport this model somewhere, you would always want to have this shipped flat, just the way that that's shown here. And you would also, if you're shipping this anywhere with a shipping company, you always want to have it shipped as freight on a pallet. The cost for the storage case is $4,799 per unit. So at this point, if you did have any questions, this would be where you could use either the question and answer window on the Zoom toolbar, or you could use the webinar chat window that's also on the Zoom toolbar. If I don't see any action, I'm just going to move to taking the next step. So essentially, if you would like to take the next step, if you'd like to request our current fischertechnik Higher Education and Industry Guide, which we have both as a PDF version, if you'd like that emailed, or we have a printed copy we can send you. You can get either of those. If you would like to get a formal quote for this unit, if you would like to speak with your dedicated educational representative, depending on what state you're in, there are different reps that handle different states. We would put you in touch with any of them. You can do all of that by calling us here at our office. The number for Studica US is toll free. It's 888-561-7521. You can make any of these inquiries by emailing us at info@studica, studica.com. So you can email us with any questions you might have that way. If you did have any questions for me specifically, again, I mentioned, being able to send you information on specific models, this model, other models we have, send you the PDF, what have you. You could also email me directly. My email is lance.zurek, lance.zurek, again, at Studica, studica.com. So on that note, thank you very much for taking the time to attend today's presentation. We look forward to hearing from you soon. Have a great afternoon.